MBA633 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this segment, we will see how to use Excel's built-in function to compute probabilities associated with the t-distribution. Now, the t-distribution is also a continuous probability distribution. It's also bell-shaped. It looks very much like the normal distribution, but it tends to be a little squatter. I mean, a little shorter and fatter. Okay. Now, every t-distribution has associated with it something called degrees of freedom. I've represented it here by df. Okay. And the larger the degrees of freedom, the more spiky or more peaked this bell-shaped curve becomes. And in fact, once degrees of freedom exceeds about 100, the t-distribution becomes pretty much identical to the standard normal distribution. The mean of the t-distribution is 0, and if you remember, the standard normal distribution had a mean of 0 and a standard deviation of 1. So the t-distribution has a mean of 0, but it's fatter and shorter. But as the degrees of freedom increases, it becomes more and more, it becomes narrower and narrower. And ultimately, when the degrees of freedom becomes very high, let's say 100 or higher, then it pretty much becomes identical to the standard normal distribution. Unfortunately, unlike the norm dist, norm inverse, norm s dist, and norm s inverse functions that you use, the t dist and t inverse functions that you have in Excel are a little messier to use, and we will see why. So you have to keep track of which area under the curve Excel works with, and that's takes a little practice. Okay, so let's work some problems and you will see the differences with norm s dist and norm s inverse. But conceptually, you're doing the same thing. When computing probabilities with any continuous distribution, you're computing areas under a curve. Okay, that's all the basic idea is. The only complication is the Excel built-in functions work with either left side or the right side areas, and that's what you have to keep track of. Okay, all right. So let's see the first problem. I want the value of the probability of t being greater than 1.5. We know that the t distribution has a mean of 0. So the probability of t being greater than 1.5 is the area under the curve to the right of 1.5. Is this portion that I've just traced out with the cursor. Okay, it's the area to the right of 1.5. So since I know my position on the x-axis and I want the probability, so I will use dist. So it's t dist. So it says, okay, what's your position on the x-axis? It's 1.5. Degrees of freedom for this, all the problems that we are working here for this tutorial is 10. We'll just assume it's 10. And notice that there is a third parameter says tails, and this parameter can either be 1 or 2. Basically what he's asking is, do you want only the area to the right of 1.5, or do you want twice that area? Now, why would one want twice that area? You will see later on that there is something called hypothesis testing where you might want 2 tails. But what do the 2 tails mean? If I were to put 2 over here, then basically what I'm saying is, give me the area to the right of 1.5 plus the area to the left of minus 1.5. Okay, so that's not what I want. I only want the area to the right of plus 1.5. So I will put the value 1. All right. So the main distinction you have to remember between t and the normal distribution is that the t distribution either works with right side areas or with 2 tails. And that takes a little practice, just keeping the norm and the t sorted out. So the probability of t being greater than 1.5 is 8.2%, 0.082. Let's use the same logic and see what we get over here, and we will run into a problem. The probability of t being less than 1.5 is of course the area to the left over here. So let's see what happens. Obviously I'm going to use a Tdist function since I know my position on the x-axis and I want a probability. So I have Tdist and my position on the x-axis is minus 1.5, isn't it? Degrees of freedom is 10, and since I want 1 tail, I will put 1 over here, and immediately it gives an error message. It says num, So the Tdist function does not allow you to put negative inputs. All right. So are we out of luck? No, we are not. We simply have to take advantage of the fact that the T distribution is a symmetric distribution. Okay. What does this mean? It simply means that the area to the left of minus 1.5 is the same as the area to the right of plus 1.5. And the Tdist function, as I said a minute ago, only works with right tails or two tails. Okay. So what I will do here is I will trick Excel into thinking that I want the right side tail, and I put 1.5, and it gives me, oops, sorry, the other things I have to provide. 1.5 degrees of freedom is 10, and I want one tail, so I get the same number. Okay, what did I do here? Okay, I did it correctly. Whereas 8.2%. So the area to the right of 1.5 is also 8%. The area to the left of minus 1.5 is also 8.2%. But the reason I did this second problem is just to impress on you the fact that the Tdist function does not accept negative inputs, and you have to do some mental gymnastics to figure out what is the corresponding area on the right that you need. Okay, so the third one, what is the probability of T being between 1.5 and 2? So it's this area between 1.5 and 2, the area that I've just traced out with the cursor. And the Tdist function will not give you that directly, but I think you can guess by now what sort of geometry swapping of areas that you have to do. If I can get the area to the right of 1.5 and I subtract from that the area to the right of 2, then I'll have the area that I will need. So this would be equal to Tdist of 1.5, 10 degrees of freedom, one tail to the right, minus the area to the right of 2. So Tdist 2, 10 degrees of freedom, one tail. So it's 4.5%. So the probability of T being between plus 1.5 and plus 2 is 4.5%. Now let's look at the last one. What is the probability that P will lie between minus 1.5 and plus 2? Obviously, I cannot get this area directly. Okay, so how do I go about getting this? I know I can get the area to the right of 2, and I can get the area to the left of minus 1.5 by doing some mental gymnastics. So let's see how we would go about doing this. The area to the right of 2 is Tdist 2, 10, 1. Correct? 3.6%. Now the area to the left of minus 1.5 is the same as the area to the right of plus 1.5, isn't it? So we will say equal to Tdist 1.5, 10, 1. Okay, so it's 8.2%. So this 3.6% is the area to the right of 2, 8.2% is the area to the left of minus 1.5. Now if I add these two up, 11.8% is the area to the right of 2 plus the area to the left of minus 1.5. Now all I have to do is subtract it from 1. Okay, so 88.1%. So the probability of T being between minus 1.5%, 1.5 and 2 is 88.1%. So it's a little mental gymnastics it takes simply because of the way the Tdist function works. Now let's look at the reverse, which is the T inverse. So find T such that the area to the right of T is 1.5. Since I know the probability but I want my location on the x-axis, I would use the T inverse function. Now notice the inputs that T inverse requires. T inverse requires a probability and degrees of freedom. Unfortunately, as I mentioned in class, the T inverse function always works with two tails. So since I want the area to the right of t to be 0.15, that's one tail. So 2 tails is 0.3. So the input I have to give here is 0.3, not 0.15. Okay, so degrees of freedom is 10. Oops, mistyped. Let me correct this. 1.09. In other words, the area to the right of 1.09 is 0.15. But notice that the input that I have to give for the probability is 0.3, twice the probability that I want, because the T inverse built-in function only accepts 2 tails. It works with 2 tail probabilities. Okay. Same here, find t such that the area to the left of t is 0.15. Now, since the average, the mean of t is 0, and if I want the area to the left of t to be 0.15, then obviously I'm looking at a negative number. Okay. Now, the t inverse function will never return a negative number. We know that from how Tdist behaves. You'll have to swap the sign mentally yourself. So what input do I give? So I need to use the T inverse function because I'm looking for a location on the x-axis. So again, the area to the left of t is 0.15. That's one tail. So I have to give as an input the probability of 2 tails. So this will be 0.3 again, and I give 10 degrees of freedom, and I get the same 1.09. But I have to put a minus sign in front of it myself. So the answer is minus 1.093. Notice that T inverse did not put in that minus sign for me. I have to put that minus sign in based on my knowing that the T value has to be negative. If the area to the left is 0.15, then that value has to be to the left of 0. T value has to be to the left of 0, so it has to be a negative number. Okay, so a little bit of mental gymnastics, but you do work a few problems, you'll get used to it. Last one, find t such that the area between minus t and, so here's minus t, here is plus t. I want the area between the two be 90%. This one's easy because if the area between minus t and plus t is 90%, the area in the two tails together is 10%. So what input do I put? Since T inverse requires the probability of the two tails together, I put a 10% here, and the degrees of freedom is 10. So I get 1.81. So what is the answer? The answer I will say is the area between minus 1.81 and plus 1.81 is 90%. So this is how you use the T inverse function. The Tdist and the T inverse function take a little more practice and getting used to compared to the norm. So make sure you practice this function well, because this is what you will need to use. Also, Excel 2010 has 2 or 3 additional Tdist functions that I'm not showing you, just to be consistent with 2007. Some of you are using Excel 2007, some 2010. So I'm just showing you the built-in functions that are available in both versions. Okay.